Hello everyone. Welcome to the official YouTube channel of Cloudways. We are the students of Government Polytechnic, Nagpur. And we are creating a project on the topic named as Cloud Computing. We are creating this playlist for our college project which is named as Software Project Management. So, our today's topic for this video is Cloud Load Balancing and Security in Cloud Computing. Now let's see the contents for our today's video. First is Cloud Load Balancing. Next is storage of data in cloud. Next is security issues in cloud. And the last one is cloud security. Now let's learn about load balancing and security in cloud. And if you like our videos, then do like, share and subscribe our channel to get a detailed information about cloud computing. Cloud load balancing. Cloud load balancing is the process of distributing workloads and computing resources in a cloud computing environment. Load balancing allows enterprises to manage application or workload demands by allocating resources among multiple computers, networks, or servers. Cloud load balancing involves hosting the distribution of workload traffic and demands that reside over the internet. Cloud load balancing helps enterprises achieve high performance levels for potentially lower costs than traditional on-premises load balancing technology. Cloud load balancing takes advantage of the cloud's scalability and agility to meet rerouted workload demands and to improve overall availability. In addition to workload and traffic distribution, cloud load balancing technology can provide health checks for cloud applications. To avoid noisy neighbors and poor application performance in a public cloud environment, cloud load balancing uses virtual local area networks, VLANs, which group network nodes in various geographic locations to communicate as if they were in the same physical location. Storage of data in cloud computing. Cloud storage is a service that allows to save data on off-site storage system managed by third party and is made accessible by a web services API. The data which we store on cloud is stored in storage's devices. Storage devices. Storage devices can be broadly classified into two categories: block storage devices, file storage devices. Block storage devices. The block storage devices offer raw storage to the clients. These raw storage are partitioned to create volumes. File storage devices. The file storage devices offer storage to clients in the form of files, maintaining its own file system. This storage is in the form of network attached storage (NAS). Cloud storage classes. Cloud storage can be broadly classified into two categories: unmanaged cloud storage, managed cloud storage. Unmanaged cloud storage. Unmanaged cloud storage means the storage is pre-configured for the customer. The customer can neither format, nor install his own file system or change drive properties. Managed cloud storage. Managed cloud storage offers online storage space on demand. The managed cloud storage system appears to the user to be a raw disk that the user can partition and format. Cloud storage system. The cloud storage system stores multiple copies of data on multiple servers, at multiple locations. If one system fails, then it is required only to change the pointer to the location where the object is stored. To aggregate the storage assets into cloud storage systems, the cloud provider can use storage virtualization software known as StorageGrid. It creates a virtualization layer that fetches storage from different storage devices into a single management system. It can also manage data from CIFS and NFS file systems over the internet. Now let's see security issues in cloud. Security issues in cloud computing. Confidentiality. Confidentiality is a serious issue in cloud computing, as you are the authenticated user of the data uploaded on the CSP. This is the responsibility of the cloud service provider, CSP, to maintain the data confidentiality. Let's take an example. Imagine that user A is transferring data through internet to user B, so no third party is allowed to see the data, is known as data confidentiality, and if someone other than user and B are able to see the data, means the data confidentiality is not maintained. Integrity. Data integrity simply means the data of the cloud user should not be modified, means no one should be able to modify the data rather than the authenticated user, and the responsibility to provide this is of CSP. Availability. Availability means providing services by 24/7 to the paid user of the CSP, means there should not be complaints that the CSP is not providing any kind of service to a paid user of the CSP, as he is providing money to get that service from the CSP. Authentication. Authentication means providing services only to the authenticated user, which is generally checked by providing proper user ID and password. Authorization. Authorization means authenticated user should only get the services which he had access rights. He should not get the access of the unauthorized services of the CSP. Data access. For data access, let's take an example of an organization which had saved data of 500 TB in a database. To log in, the org would have made a lot of login ID and pass which would have different access rights, which means there would be many employees in that company, so all the employees would not have the same data access. Therefore, there should be some mechanism on data access in the CSP. Data segregation. In the cloud, all the world stores their data, so the CSP should ensure that our data is segregated from the rest of the world, means our data should be not get mixed with the data of the other world. Privacy. The CSP should provide privacy to the user, means CSP should hide the private details of the user, like the user is using which OS, the IP address of the user, how much amount of data storage is purchased by the user, and etc. Recovery. Data recovery is the responsibility of the CSP to maintain many duplicate copies of our data in many data centers, means CSP is responsible to maintain our data, and as if the data got deleted, it's the responsibility of the CSP to recover the data portability. Imagine that you are using Google Cloud Platform, GCP, as your CSP, and you are not happy with the services provided by them and you want to port your data to Amazon Web Services, AWS, so GCP should allow you to port your data from GCP to AWS without losing your data, so this is the simple concept of portability. The last subtopic of our today's video is cloud security. Securing your system falls in three main levels of responsibility. First, JS, things you're responsible for. Second is things your provider is responsible for. And things you're both responsible for. There is platform, infrastructure, and application level security. The user is responsible for securing their applications, like setting up proper authentication, authorization, and identification for user in their system. The cloud service provider, CSP, is responsible for securing the platform, which includes managing the physical machines and data centers, your application and data use. Lastly, infrastructure security is a shared responsibility, where the CSP provides tools to help the user manage their VMs, network, and data access needs. Let's explore this in depth. What do you have to do to secure your cloud environment by yourself? I know that. Within these levels of responsibilities, there are three main security actions you can take to harden your system. First is platform and infrastructure actions. Second is preventative actions. Third is forensic actions. Platform and infrastructure actions. Infrastructure and platform actions are steps you take to make sure the underlying hardware, or virtual hardware, are secure. There are two components of this: platform security, which CSP completely manages, and infrastructure security, which is managed by the user but the CSP provides tools to help. Platform actions are steps CSP takes to secure the hardware and software tools available over the internet they provide to users. This could be anything from physically securing data centers to replicating data across regions to make sure it's available even in the event of a natural disaster somewhere. Infrastructure actions, on the other hand, are the steps the user takes to secure the cloud-based pay-as-you-go services such as storage, networking, and virtualization that Google provides. This could be anything from changing settings in a load balancer to selecting a more secure VM instance type for your application. Preventative actions. The next class of the actions is preventative actions. These are steps to avoid breaches, like locking down access controls. Much of this happens at the application level and includes things like cloud identity and access management, or IAM, and identity-aware proxy, or IAP, to limit who has access to what inside of your system. So CSP provides tooling to the users to help define access levels. Forensic actions. And then there are forensic actions. These are the steps to track down breaches and stop them quickly, or ideally to identify and stop malicious behaviors before a breach ever even occurs. One of the main practices here is logging and monitoring. By logging activity within your system and setting up automatic and manual monitoring of that data, you can be alerted of suspicious activity before it's too late. The cloud service provider, CSP, provides tooling to help customers monitor their environments. Security of physical premises. For securing our data, many data centers are made. Securing these data centers is the topmost priority of the cloud service provider, so there are a lot of security concerns made by the provider. So let's take an example of Google Cloud Platform, GCP. There are 6 layers of security provided by GCP in a typical Google data center. Layer first includes boundary wall and fencing provided with anti-climb feature. guards outside the premises, thermal cameras and vehicle crash barrier, and etc. Layer 2 starts with the main entrance gate with smart fencing, overlapping cameras, and 24/7 guard patrols. Layer 3. A card is essential for every employee to enter in Layer 3 also, as if someone misplaces their card, you also have to scan your eyes to ensure that she is the real employee. One thing that is essential when you are entering a secure area: only one person is allowed to enter the door at once by scanning their ID card. Layer 4. Layer 4 includes the Security Operations Center, or the SOC, which is monitoring the data center 24/7 and 365 days a year. All the security checks, ID scans, eye scans, are cross-checked here. Layer 5. An interesting fact about the Layer 5: the data center floor, less than 1% of Googlers ever gets to set foot in here. Only the necessary technicians and engineers to maintain, upgrade and repair the equipments are allowed there. Also, the employees there have access to the devices used there, but the data is encrypted and the customer can issue and keep their own encryption keys. Layer 6. In the Layer 6, the disks are erased and destroyed and a very few number of people are allowed to enter. Drives that need to be retired from the data center comes to this room, though a secure two-way locker system, which means that only technicians assigned can pull the drives from the lockers to either erase or destroy them. Before destroying them, they are scanned and then transported to the crusher room. Here the hard drives are totally crushed. At the end, when anyone is leaving the data center, she has to go through a full body metal detection each time they leave the data center floor. Thanks for watching this video up to here. We hope you get a detailed information about our today's topic. For more videos, do like, share and subscribe to our channel. Thanks from Team Cloud Ways.